Hi everybody, here is a video for section 12.3 and it will prepare you to do homework number 46. Okay, so last 12.2 was a little bit, wasn't as much complicated, there was just a lot to it. I think you'll find that this one is quite a bit simpler and hopefully will allow you to kind of put things together. So, okay, in section 12.2, we learned how to find the surface area. Remember, like we're wrapping a piece of paper around the surface of prisms and cylinders. So we learned prisms and cylinders, okay? In section 12.3, we're going to learn how to find the surface area of pyramids and cones. So let's take a look at these four figures first, because they have a lot in common, even though they look kind of different. So you notice, we learned about prisms and cylinders. Okay, prisms and cylinders. And what do you notice about the difference with them? Okay, they both have bases, right? In a prism, the base is a polygon. Okay, it can be any polygon. In this case, it's a rectangle. And here, a cylinder has a base, but it is a circle. Okay. And also, we notice that the heights on a prism and a cylinder are vertical. Okay, so they are similar in that their heights are both vertical. They're dissimilar in that their bases, one is a polygon and one is a cylinder. I'll change colors here. So the deal with pyramids and cones, which we're going to be working on today, okay, is very similar. So a pyramid, like a prism, has a polygon for a base, a polygonal base. So it can be a hexagon, a square, a rectangle, triangle, whatever, okay? But like the prism, okay, it has the base of a square. Similarly, a cone has a base of a circle, just like the perimeter did, okay? But what's the difference? So with a pyramid, instead of the sides being vertical like they are in a prism, the sides are slanted. Okay? And with the cone, it's the same deal. Instead of the side being vertical like it was in the cylinder, it's slanted. Okay? So really what tells all of these things apart is the shape of the base and whether or not their heights are vertical. So it turns out that the formula for surface area for all of these various objects are very similar, but you're just taking, the only thing that differentiates them is that you're taking into account the type of base they have and whether or not you have a vertical or a slanted height. So it turns out in the types of solids that have vertical sides, remember in the formulas we talked a lot about height. Well, for pyramids and cones where the heights are slanted, we're going to talk about a slant height. Okay? And slant height is just this height that's slanted. Okay? Whereas these heights were just plain old heights that are vertical. Okay, so I'll deal with this also in another slide, but I just kind of wanted to alert you to that. So these formulas should look very familiar to you. Okay, they should look really similar, and sometimes if we look at it like that, they're not quite so scary. So here you have the surface area of a regular pyramid. So what does regular mean? Okay, the same thing it did in the other context where the polygon that is the base, the sides are all equal. Okay, So the surface area of a regular pyramid is equal to the base, okay, the area of the base, okay, plus 1/2 times the perimeter of the base. And here we go with the new thing, that's slant height. Okay, so the area of the base is this yellow part down here. Okay, P is the fence or the line around the base, and the slant height is going to be this line right there. The line is actually on the face that's slanted. And notice that the letter that we use for slant height is a script L. So it's really easy to make, just like that. And remember that your base can be any regular polygon. So its sides are going to be straight. There's no circles in there. And the sides are all equal. So let's look at a problem. Okay. So this one is from your book, so you can look at it. So here we have here we have a regular hexagon, okay, for a base. A hexagon has, hopefully you remember, 6 sides. And here's our hexagon right there. And what they did, and what I suggest you do, particularly when you're starting out, because the base is so important, that when you figure out what the base is, when you're given a solid, and you figure out what the base is, go ahead and draw it. Just draw the base. Forget about the height for a minute, okay? And just draw the base, and that'll help you figure things out. So remember, the base is a hexagon. It has more than 4 sides, so in order to find its area, we have to use that equation 1/2 A times P, where we need the apothem. Okay, and you all remember how to get the apothem is that you divide the base in half. Okay, so it's half of this. I'll change colors. Okay, it's half of this. Here's your hypotenuse. The apothem is your other height, and you use your a squared plus b squared plus c squared. Actually, I shouldn't write it that way. I should write, come here. Okay, here's your triangle. Here's your apothem. Okay, so your apothem is going to be right there. Okay. And then you can use b for that and c, and we use good old Pythagoras, a squared plus b squared equals c squared. Okay, and you guys know how to do that. So to find the base, you're going to use the formula 1/2 AP for the area of the polygon, and you're given conveniently that the apothem of the hexagon is 5 1/3 feet, 5 and square root of 5 times the square root of 3 feet, and the perimeter is 6, that's the number of sides, times 10. You're given that one side is equal to 10 feet, so that's 60 feet. So the area of the base is going to be 1/2. Here's your P, and, no, that right, yeah, sorry. 1/2 your A, and here's your P. Okay, and you plug in those numbers and you come out with 150 to the square root of 3 square feet. So this is your base area. Okay, and we plug in our 150 square root of 3. And the rest of our formula is 1/2. So we put in 1/2. We know our perimeter, which is 60. And how did we get our slant height? We're given our slant height. There it is, right there. Slant height, 14. Okay, you do the math with that. You plug in your calculator for the square root of 3, and you come up with a total of 679.81. Okay, so once you get all that straight, it's just a matter of plug and play. And you'll notice this is very similar to the the equation for a pyramid, except, for a prism, but a prism has an H right there, okay, instead of the slant height. So that's how to find a regular hexagonal pyramid surface area. Okay, so let's look at a cone. So here we have the base. Okay, in this case, the base is a circle. Okay, so the area of a circle is pi r squared. Okay, and then 1/2 the circumference, which is this length around here. Okay, and it's just kind of like it's the same idea as a perimeter in a polygon. Okay, so we've got the circumference is 2 pi r. Okay, and so here's our pi r, and then we have, instead of our h, we have our slant height, which is L. So hopefully that makes sense, and we can go ahead and do a problem. So here you're going to find the surface area of a cone, and in all these problems they're asking you to round it to 2 decimals, which is generally a good idea. When you get to Algebra 2 next year, your teacher may decide he or she wants 1 number to the right of the decimals. I'd say most use 2. Very rarely you'll get a teacher who wants 3. So that's kind of why we're practicing the 2 right now. So here we have a cone, and make that a better E. And we know the formula for surface area of a cone is pi r squared plus pi r times our slant height. So we're given our radius is equal to 5. We're given our height. Okay, notice this 8 feet here is not the slant height. This is the height of the cone. And our height is 8 feet. Okay, but we're not given the slant height. The slant height would be this height right there. So what do? Well, you make a triangle. So when in doubt, always make a triangle. So here we have a triangle, and our height is h. This base here is 5, and this is going to be our slant height. So again, dear old Pythagoras, we get 5 squared plus 8 squared equals L squared. Okay, we figure all that out, and it turns out the square root of 89 is equal to L, and L is equal to 9.43, and I've rounded it to 2 decimal places. So let's plug that into the equation. So I have pi, my r is 5 squared, plus pi times r times slant height. Remember, the basic equation was S equals pi r squared plus pi r L. Okay, and here, cat, go away. The cat is pushing my hand. Okay, I L is 9.43. Yikes. There we go. So that comes out to 25 pi plus 47.15 pi. You combine those, it's equals 72.15 pi, and you use 3.14 for pi, and you get 226.15 0.55 feet squared. Okay, so we just found the surface area of the cone. So again, that's like we wrapped a piece of paper around the cone with no overlays, no overlying edges, and no extras. Okay. So here, before we do a couple more problems, I just wanted to show you this, and this may help you, it may not, but it might help you organize your thinking. And this is all of the shapes that you're going to work with in chapter 12. So if you can get these firmly in your mind, you're doing really well. What we're going to do in 12.5, see 2, 3, 12.4 and 12.5 is we're going to do the volume of these shapes. Okay, now we're working on surface area. But in the next two sections, we're going to do their volume. And you're going to see the same similarities between their formulas. Okay. So here, this column, your base is a regular polygon. Okay, this is a prism. I should have put the things on there. Okay, and your base... Come on. Your base is a poly. Okay. Here, for a pyramid, your base is a poly. Okay, it can be any poly. Okay. And on this side, your base is a circle. So here you have your cylinder, your base is a circle, and your cone, the base is a circle. Okay, so that's what sets those guys apart. Now, on this vertical side, we have sides are vertical. Okay, here's my vertical side, here's my vertical side, and down here in this row, sides are slanted. Okay. So let's look at their equations. So let's look at the first column. So here we have the surface area is equal to 2 times the base plus the perimeter times the height. Now for a pyramid, you don't have two bases. You've only got one base, so you just have a B. And then instead of the perimeter times the height, okay, you're going to have the slant height, which is L, and because you don't have that top base, okay, so there's a lot of area that's missing there, you're going to have to divide the perimeter by half, okay? So going over here, the second column, your base is a circle, so you're going to have your base plus the circumference, which is like the perimeter of a circle, times h, and then we know we can use pi, and twice the area of the base is 2 pi r squared, plus 2 pi r, which is the circumference, times h. Now you come down here, and it's the very same thing, except you only have one base, so you don't need that 2. Okay, there's only one base there. And you don't need the 2 pi r, okay, because there's that other part missing. And here's your L. So instead of the H, you have the L. And here it's the same deal. Instead of the H, which you have in these, you have the L, because in the top row, the sides are vertical, and in the bottom row, the sides are slanted. Okay, so they are very similar. It's the base times the height. Okay, something to do with the height. So it all makes sense if you think about it, and hopefully that makes things a little bit clearer for you, at least of how all these things work together. Okay, so let's do some problems. So surface area of a pyramid. Okay. So our formula for the surface area of a pyramid is base plus 1/2 perimeter times L. Okay, notice our base is a triangle. Okay, base is triangle, so that's the first thing that you really need to notice when you get handed a problem with a solid on it. What is the base? The most important thing. Okay, and since it is a regular triangle, okay, regular triangle, all sides are equal. Okay, so this is equal to 5, and this side over here, that length is equal to 5. Okay, so let's start working on our equation. So we have the base is a triangle, so the area of a triangle is 1/2 the base times the height, and what we'll do is we'll draw our base. Okay, we know we have 5, 5, and 5. Okay, and so our base is equal to 5, and our height is equal to 5. So that's equal to 55. 5 times 5 divided by 2 is equal to 12.5. Okay, our perimeter is going to equal 5 plus 5 plus 5 equals 15. So that's the route around there. Okay, and then our slant height L is given to be 8. So let's do our equation. S is equal to 12.5 plus 1/2, 15, our perimeter, times our slant height, 8. And long story short, that's going to be about 72.5. Okay? So that's that problem. This is number 8 on your homework sheet. So you get to do 6 and 7. I did 8 for you. Okay, surface area of a cone. This is number 13. Okay, so I'm doing 13. Numbers 14 and 15 are left for you. So here our surface area is equal to pi r squared plus pi r times the slant height. Okay, we're given our r is equal to 4. And we're given our L is equal to 15. How easy could that be? So it's really just plug and play. So our S is equal to pi times 4 squared plus pi times 4 times 15. Long story short, that's equal to 76 pi. And use your calculator for 3.14 for pi. And you're going to come up with 238.76. In this case, it's inches squared. Okay, so that's it. And hopefully that works out pretty well for you. And be prepared for the next one.